Hey everyone, today we're going to be solving problem 16 of the 2000 AMC 10 test, so let's start. The diagram shows 28 lattice points, each 1 unit away from its nearest neighbors. Segment AB meets CD at E. Find the length of segment AE. Well, we know that E is an intersection of CD and AB. We also know AB and CD are segments. So what we could do is we could find lines, the equation of the lines CD and AB, and then we could find the coordinate of E. And then using that, we could find AE. So let's do that. So I'm just going to define the y-axis here and the x-axis here. My lines are not as straight as I want. But anyway, now let's find the equation of AB. We know that A is 0, 3, and B is 6, 0. So now we just have to find the slope. And we know the slope formula is a change in y upon the change in x. So the change in x would be 0 minus 6 equals to negative 6. And the change in y would be 3 minus 0 equal to 3. We can simplify this to negative 1/2. Now let's write the full equation. Y equals negative 1/2 x plus 3. The reason we know it's 3 is because we know that this part over here is a y-intercept, and we know that A is a y-intercept, or the y-intercept is basically the part that crosses the y-axis. And we know that coordinate is 3, and therefore it would be 3. So now let's find the equation of CD. CD, we just do the same thing. So we know this point over here is 2, 0, and we know this point over here is 4, 2. Right? And then what we do is we find the slope again. So 2 upon 2 equals to 1. And so it's y equals to x minus 2. And we know it's minus 2 because these are the 2 points, and it would need these equations to satisfy those 2 points. Now we can erase all of this. Let's draw back our x-axis, and then let's find point E. To find point E, we just have to find the x and y. We have to find x and y such that they satisfy both of these equations. Now, one way we could do this is we know that we have y here and y here, so we could set these equations equal to each other. Let's do it. X minus 2 equals negative 1/2 x plus 3. Now let's bring all the x variables to one side. 3 upon 2x equals 5. 3x equals 10. X equals 10 upon 3. And then we know by this equation over here, y would equal to, we just subtract 2, 4 upon 3. Now we can erase all of this because we don't need the equations with the line anymore now that we know the coordinates of point A and E. Now we can use a distance formula, or what is basically Pythagoras. But anyways, let's use it. So in case you don't know, when we have to find the distance between 2 points, all we do is we have to find this length, basically subtract the x coordinates, subtract the y coordinates, square them, and use, it's kind of like Pythagoras. A squared plus b squared equals c squared. So, let's draw back this. And so let's do it. So we know that this point is 0, 3. And this point over here is, well, we just got it here. 10 upon 3, 4 upon 3. So what we can do is we know that 0 minus 10 upon 3 plus 3 minus 4 upon 3, and we have to square these. Square root would get our answer. Now, instead of doing all this heavy calculation, I'm just going to let you know the answer is 5 square root 5 upon 3. So, in other words, the answer is B. So we can circle our answer on the test, and we will know that we got it correct. Please like this video and don't forget to hit the subscribe button. Thank you!